Okay, hopefully it didn't take you too long to do this homework. There's a couple of problems you might have had to stop and think about, but here we go. All right, the first one I've asked you to do is find the velocity of each car by finding the slope of the line. Now, obviously, you can look here and say, well, if A went 3 meters every second, it's going 3 meters per second, and if B goes 5 meters each second, it's going 5 meters per second. But what we're trying to see here is simply this, that the slope of the line that we get. So if I take the slope of this line here for A, and if I find the slope of it, what I'm going to find is, first of all, let's just try drawing a line here. Okay, and this could be disastrous. I don't know. Let's just see here. I'm going to try to draw a line for A. Okay, I'm going to try to make it red. It's hard to draw with this. I'm going to go, oh, see, it's not red. Darn it. Let's try drawing red now. Here we go. I'm going to draw a red line. That's a terrible line. And I'm going to draw a blue line here. Okay. Okay, let's start with a red one. All right. Basically, if there wasn't any scatter today, there's a bad drawing of my line. I'm gonna go up here. I'm gonna try 12. I'm gonna say at 12 it was 4. So I'll just say for A, what we have is 12 meters divided by 4 seconds, and lo and behold, super surprise, 3 meters per second. But the point is that we look at B. B has a steeper slope, therefore B has a slope or velocity, because on a distance versus time graph, the slope of the line is how fast the object is traveling. Actually, it's its velocity, because a positive slope implies a positive velocity and a negative slope implies a negative velocity. So B has a positive velocity, and if we also go for, say, 12, let's see right here, let's see what we should get. If I draw it correctly, we get something around, let's see what we have here. Now let's go for 20. Let's go to, at 20, it's 4. Let's try that. So we have here for B, we have 20 meters divided by 4 seconds, and what do we have? We've got 5 meters per second. So the takeaway here is on a distance versus time graph, and there's also going to be velocity versus time, and there's going to be acceleration versus time, but on a distance versus time graph, the slope of the line is the velocity of the object. Positive slope, positive velocity. Let's keep going, not belabor the point any more than I already have. Alright, let's go to the next one here. So I've already graphed it because it takes a while. So here what I've got is, for these oil drops here, what I see is this one is starting slow and getting faster. I should have a positive acceleration. This one is starting fast and going slower in a positive direction, so I should get a negative acceleration. So I use red to represent car A. So we see car A starts off slow and the slope gets steeper and steeper. Remember, the slope of the line is how fast the car is going. So this one starts out having a low slope, meaning a slow positive velocity, and with each passing moment it gets a steeper and steeper slope, meaning it's going faster and faster. If I look at the blue one, it starts off with a steep slope, and that slope gradually curves downwards, indicating that this object is slowing down and will eventually stop. So this, what we have here is an acceleration, but since I'm slowing down in the positive direction, this one here represents a negative acceleration, a slowing down in the positive direction. So let's see what we get here. Now I got to move this a little bit. Alright, so how fast was object A, that's the red one, going between seconds 1 and seconds 2? So let's just see how far it went. Here it's at, it looks like 0.5, and here it's at 2. So the difference I get there is 1.5 meters per second. That's an average speed. It's changing the whole time, but the average speed between those 2 points would be 1.5 meters per second. And now between seconds 6 and 7, so let's see what we have here. Between seconds 6 and 7, it changed 2, 4, 6.5. So I'm going to call it 6.5 meters per second. So you see, it starts off slow with a low slope here of 1.5, and then it gets a steeper slope. As it speeds up, it's got a positive slope of 6.5. Let's try it with object B. So between seconds 1 and 2, so here's second 1, here's second 2, it changed 2, 4, so its average speed between those two was 4 meters per second. Pretty fast. Now what happens though is between seconds 6 and 7, Here it is at second 6. Looks to me like it's maybe at 24, and it ends up at 25, so that's half a meter. So in that last second, it only went let's make it 0.5 meters per second. So you see, it started off fairly fast, and then as the slope got lower, it got slower. Now it stayed positive. It wouldn't be negative unless it started coming this way in the negative direction. Alright, now you really get into it. So what you've got to do is you've got to learn to look at this and remember this. The slope of the line on a distance versus time graph, which all these are, each of the graphs above is represent, it should say distance versus time graphs. Here's distance, here's time. What we see is if the slope is flat, you're not moving. If the slope is, because your slope is 0. If your slope is in a negative direction, you have a negative velocity. If it's in a positive direction, you have a positive velocity. Now, anytime your slope gets steeper, you're getting faster, regardless of whether it's positive or negative. So look here, this one's getting steeper, so that's one's speeding up, and it's moving in the positive direction, the upper direction. So this would be speeding up in a positive direction, a positive acceleration. Now this one has a slope that's getting steeper in a negative direction. It is getting steeper, but it's getting steeper in a negative direction, so this would have a negative acceleration. Now, so let's just, and when they move towards a flatter, remember, flat is 0, so this one starts off steep and becomes flatter, so this one is slowing down in a positive direction. Well, that's a negative acceleration. This one here, we see this one here starts off with a high negative velocity and gets less, and so it's slowing down in the negative direction. That's a positive acceleration. So let's just try this here. Alright, here we go. Alright, which of the graphs above depicts an object traveling with a constant velocity in a positive direction? Constant velocity in a positive direction, that would be F. How about an object traveling at a constant velocity in a negative direction? There it is. That would be object D. Do I hear my wife's cell phone? I do. Hang on, I'll be right back. Well, it was Miss Fisher trying to call my wife and having to leave a message. Okay, now let's try another one. How about an object that is not moving? That means it has a slope of 0. There you have it, B. An object that is slowing down in a positive direction. It's moving in a positive direction and it's getting less and less steep, and therefore has less velocity. That would be C. An object that is slowing down in the negative direction. This object is moving in the negative direction and getting slower, so that would be A. An object that is speeding up in the negative direction. This one starts off with a gentle slope and gets steeper, so this one is speeding up in a negative direction. That's a terrible E. And an object that is speeding up in the positive direction would be this one here. Starts off low and gets higher, so that's G. Now, so far so good, but let's look at this next section here. Oh my gosh. Let me make this one a little bit larger here. Alright. On the graph above, which line segment represents the object when it's not moving? Now, when it's not moving, it has no velocity, it has a flat slope. That'd be this part right here. So I'll put line segment BC. When it is speeding up, now you might have a tendency to go, well, heck, it's speeding up here, right? That's true. It went from nothing to something. But if you look at this, all this the speed I'm having right here, because now the slope is getting more and more and more gentle till it has no slope at all. So actually, it's slowing down throughout this. It's actually speeding up here, because right now its velocity is 0, and it's getting steeper and steeper. It's going faster and faster and faster. It's just doing it in a negative direction. So it's speeding up during line segment D, E. I don't know if that E was any better. How about traveling at a constant velocity? Well, that means it has a constant slope. That would be line segment AB. And it's slowing down. Well, I already said this is the section where it's slowing down. It has a high velocity here, a steep slope. The slope gets more and more gentle until it reaches 0 at D. So that would be C, D. Okay. Alright, let's just look at this next one here. We're going to draw a distance time graph that depicts the following events. Alright, here we go. Wish me luck. Let's do it in red. How about it? Alright, so what we've got is a person steps out his front door at time 0. I'm going to make this a little bit bigger. Hang on a second. Let's go here. Okay. So what's going to happen is this person is going to start at 0, walk out their door, and this person is going to go 8 meters in 4 seconds. So we're counting by twos is here. 2, 4, 6, 8. So we're on here, and we have to go over 1, 2, 3, 4 seconds. So 1, 2, 3, 4 seconds. So the next thing that happens is the person sees the bus about to leave, doubles his speed, going another 8 meters in, I can't see what it says, in 2 seconds. Okay, so 8 meters in 2 seconds, so that means I'm going to go 2, 4, 6, 8 meters, and I'm going to go over 2 seconds, which I think puts me here-ish. Okay, not very good with this stylus, I must say. The next thing that happens is the person realizes he's missed the bus and stops for 4 seconds. 1, 2, 3, here it is. For 4 seconds the person didn't go anywhere. They just sat there, 16 meters away from their doorstep, looking like a fool. Now it says he sees the bus 32 meters away in the opposite end of the street and gets there in 6 seconds. Now, that's pretty impressive. So what's going to happen is the person's going to go from 16 meters here to 16 meters at the other end of the street, the negative end of the street if you will. Alright, and they're going to do it in 6 seconds. So we're going to go, let's see, 1, 2, 3, 4, 5, 6, and down to here. Alright, so let's just try putting lines here to make it seem like it makes a little more sense. Here we go, let's see if that works. Alright, so the person had this slope. They sped up and they got a steeper slope. Then the person stopped and had a slope of 0. Then the person had a very steep slope on the way down this way. That's a terrible line. And got to there. And so they had a negative slope. So that means they were running in a negative direction. At what time did the person pass the door? Well, their pass the door would be a 0 displacement from where they started. And I see that this graph is correctly labeled distance versus time rather than displacement versus time. So when you're at your door, your displacement is 0. So whatever this value is, and if I drew it correctly, I should have found that this is equal to 13 seconds. So at 13 seconds, the person passed their door.